Okay, so first of all, in this 2022 advanced level physics paper, we are going to discuss the first 10 MCQs in this video, right? And the other MCQs 10 by 10 will be provided in the upcoming videos, right? So let's look at the first question straight away. Which one of the following pairs of quantities consists of a vector and a scalar respectively? So, like, you know what a vector is? Vector has both a direction and a magnitude, whereas a scalar has only a magnitude, right? It only has a magnitude. So if you take mass is a scalar and velocity is a vector. Therefore, this is not a correct answer. If you take power, okay, power is a scalar and speed is also a scalar. So this is also not the correct answer. Because if you take power, just like you give it like 20 watts, right? It doesn't have a direction, right? You cannot say the power is 20 watts to the left or to the right, like right. Okay, so it doesn't have a direction. So these both are scalars. Work and distance. What about work? We know distance is obviously a scalar. Same is work, right? Work is also a scalar, right? Like you can say like we have done minus 20 joules of work or plus 20 joules of work. There is plus and minus, that is true, but work doesn't have a direction, right? Work does not have a direction. You cannot say you have done work towards the right or you have done work towards the left. Okay, we cannot talk about a direction for work. And the other thing is work is measured in joules, right? It is sort of an energy. All right, so work is a scalar and distance is also a scalar. So like it is also a wrong answer, right? And then if you look at force and potential energy. What about force? Force is a vector, obviously, right? And potential energy is a scalar because it is a certain energy, right? Okay, potential energy is a scalar, right? You can have plus minus according to the magnitude, but it doesn't have a direction, right? So this is the correct answer. And what about momentum and torque? Hmm? Momentum has a direction, right? You take it as mass into velocity, right? Since this velocity has a direction, you can say momentum also has a direction. And it might have momentum forward, it might have momentum backward. So momentum is a vector. And if you take torque, torque is also a vector, right? Like, you have two types of directions in torque. You can say either it is traveling clockwise, it is rotating clockwise, or it is rotating anti-clockwise. So obviously, momentum and torque, uh, like momentum is a vector and torque is also a vector. So this is also not acceptable. So for the first one, this is the answer. All right. Okay, so now let's go to the next question. Second one, right? The magnitudes of two coplanar forces acting on a body are 11 newtons and 5 newtons. Which one of the following values could not be equal to the magnitude of the result? Okay, now let's see. First of all, let me erase this. Right, so if you take two coplanar forces acting on a body, right? Now what we are going to do is, so what we can do in this second question is, what we can do in this second question is we can like take the maximum and minimum, right? Sorry, so here what we can do is we can like, if 11 newtons and 5 newtons is acting, right? Let's say here you have 5 newton and randomly I'm drawing this, here you have 11 newton. Okay, so you should get a certain resultant like this, right? So just think for a moment how we can get the maximum resultant and how we can get the minimum result. We can get the maximum by keeping them aligned like this, right? That is equal to 16 newton. And we can get the minimum by like keeping them in opposite directions, right? So that is 6 newtons. So all other resultants you get, right? All the other things you get should be in this range, right? It can be 6 newtons, it can be 16 newtons, it can be 8, it can be 9, anything. Okay, this is a concept, right? This is a concept that you should know, right? So it can be anything between that. So the answer should be, for this question, it should be fifth one, right? It cannot be 5 newtons. Obviously, it cannot be 5. Okay. So now let's go to the third question. All right. Let's go to the third question. The quality of sound produced by a musical instrument does not depend on, this instrument depends on, right? Quality of sound. So we know that the quality of sound produced depends on the wave shape. Okay. Wave shape, or what we call timbre of sound, right? Okay. It depends on the wave shape. For example, let's say there are two sound waves produced by a piano and produced by a violin. They might have the same amplitude. Let's say they have the, right? They have the same amplitude like this. Okay. But let's say in the violin also same. But the thing is, the shape is different. See, same amplitude, same frequency, maybe. Right? But the only difference is in shape, right? So frequency of sound is wrong, because frequency of sound does not affect the quality; it affects the pitch. We know that, right? Frequency of sound affects the pitch. Amplitude of the sound affects the loudness, right? The thing is, it affects the loudness of sound. And like intensity of sound, we know that intensity is equal to P over 4 pi r square. Okay? So intensity like gives a measure of how well the sound is spread, right? How well the sound is spread. Okay, this is what intensity will tell you. Okay, it sort of talks about the energy distribution of the sound. Okay, so it doesn't have any relationship with the quality of the wave shape of the sound. So this is wrong. Wavelength of the sound. So wavelength of the sound also affects the pitch, right? Because wavelength is directly related with the frequency, right? As you know, we have an equation called V equals F lambda, right? If this speed of sound is constant, it is normally constant in air. So when wavelength changes, this frequency also changes. So finally, wavelength also affects the pitch of the sound. Okay. So this is also not the good answer. So the answer should be existence of overtones. Now, the existence of, like, let's say in one sound wave, there are two overtones per one wave. And in another sound wave, there are three overtones. So the shape in the latter sound wave is different to that of the first one. Therefore, this should surely affect the quality of sound. Okay. So the answer for this one is the fifth one, right? Okay. Next, let's go to the fourth one. A stationary magnetic field does not, does not interact with any, the same. Okay. Stationary magnetic field. Now, if something is to affect a magnetic field, right? According to the knowledge you have under the unit magnetism, right? You know that if there's a current carrying conductor, it creates a magnetic field, right? Likewise, it creates a magnetic field. Okay. I mean, simply for a magnetic field to be created or affected, there should be moving charges. There should be moving charges. Okay. So this is an acceptable answer. I mean, moving electric charges might affect the magnetic field. Okay. Current carrying wires can affect the magnetic field. You know that, right? Okay. If there's a wire like this, which gives a magnetic field like in this direction, and if we apply the same current and keep a wire in this direction, it will provide a magnetic field in the opposite direction. It will cancel off. So it affects, right? If you take stationary permanent magnet, they also affect, right? Because they are obviously magnets, right? They are definitely affecting the magnetic field. Okay. Even permanent magnets, whether they are moving or not, they will definitely affect the magnetic field. But what about stationary electric charges? They won't affect the magnetic field because they are stationary. They are not moving, right? Okay. So let's go to the next question. Fifth one. Okay. Uh, I hope you got that. Right. Let's look at this question. Back EMF in an electric motor is maximum when is maximum when the motor is not operating. Yes, they are giving some options, right? Back EMF of an electric motor is maximum when the motor is not operating, begins its operation, is increasing its speed, because they have given 5 options, right? So let's talk about back EMF of a motor. Hmm. Now, if you have a knowledge about the theory related to magnetism, you know how how an electric motor works. First of all, we should understand that. Okay, like let's say there's a power supply like this. Yeah, let's say this is a coil. Okay, there's a coil like this. So it supplies a voltage V, and therefore current goes like this, right? Current will be moving like this. This is I. This is I. Wait a minute. This is I, and here comes I. Okay, and let's say you have kept a magnetic, like you have arranged a magnetic field, right? So magnetic field is moving from which direction to which direction? It go from this side to this side, right? There's a magnetic field cut in this coil. Okay, so we can say like since current goes like this, right? Now you have a current and you have a magnetic field. Okay, so what will be produced? Surely a force will be produced, right? Force will be produced. So if there's a current and a magnetic field, and if you want to find the force, you use Fleming's left hand rule. So you can use Fleming's left hand rule, right? You can use that. So if you use Fleming's left hand rule, if you take this portion, the current is going upwards, the magnetic field is going from left to right, and you will get force into the page. Do you understand that? Force will be acting into the page. Okay, this way, right? Force is acting into the page. Suppose an arrow is moving into the page. So this is how you will see the arrow, backside of the arrow. Okay, and if you take this portion, current is going downwards, magnetic field is still from left to right. Therefore, force will be acting upwards. Okay, force will be acting upwards. Okay, so now you know there's a force acting downwards and force acting upwards. Right. So if you think 3D, what happens? This will create a moment. Okay, so you create a moment, and this coil will turn. This is how electric motors work, right? This coil will turn, right? This side will go down, this side will go up. Okay, so if you switch on a fan in your home, if you switch on a fan, this is how the electric motor inside the fan works to create that moment. All right. So another thing I should say is, let's say you have, this is something we discussed in electromagnetic induction. Okay. Now suppose you have a coil. There is no power supply, nothing connected. Okay. Just you have a coil, and there's a magnetic field. What you do is you just rotate this. I mean, using your hand, you just rotate this. You just apply a torque for this coil using your hand, right? Then what happens if you apply, like if you, let's suppose that you move this side downwards and you move this side upwards, because you are applying a torque like into the page and out of the page, right? According to laws of electromagnetic induction, right? Faraday's law, Lenz's law, you know that definitely if this happens, like an EMF or a voltage will be produced, right? Definitely it should be produced. So let's take the right side first. Let's take the right side. Let's take this side. So there's a force acting downwards. So and the other thing is, now in this situation, what do you use? Like you have the force, you have the magnetic field, current will be produced or the EMF will be produced. Therefore, you use Fleming's right hand, okay? Not the left hand this time. This time we use Fleming's right hand. All right. So if you take the right side, now there's a force acting downwards. Now take your right hand. Your thumb should be pointing downwards. Thumb should be pointing downwards. Okay. Magnetic field is from left to right. So your index finger should be pointing from left to right. Okay. So then you will see an EMF will be created downwards. Okay, or a current will be created downwards. So you will mark the cell like this. Okay. This one you can check by yourself. Okay. EMF will be created downwards. And if you take the left side, the force is acting upwards. So keep your thumb upwards and like keep your index finger from left to right. Index finger from left to right, and you see thumb is upward, index finger is from left to right, and the EMF will be created upwards. Yeah, see, the EMF will be created upwards, right? So this thing, this is what we discussed first. This is what we discussed second. Now magnetism is okay. So I hope you understood this. And this EMF can be calculated using this equation. See the theory part. Okay, you can use E is equal to BA n omega to calculate the EMF produced. B is the magnetic flux density. A is the cross-sectional area of the coil. N is the number of turns of the coil. Omega is the angular velocity of this rotation. All right. So these two things we discuss separately. But in this back EMF part, what happens is these two things, okay, I mean, providing a current and rotating the motor is the first thing. Rotating the motor and inducing an EMF is the second thing. So both of these things happen at once. All right. If you consider back EMF, both of these things happen at once. Okay. So actually, if you take a motor, right, when this starts rotating, okay, when this starts rotating, a back EMF will also be induced here. Did you understand that? I'll draw it in this color. Yeah, this way. See, and one this way. See, this voltage is produced, this current tries to flow in this direction, but this thing tries to oppose that. See, it tries to oppose that. Did you understand that? That is why it is called back EMF. Okay, so back EMF is not a complex thing. It is simply both these things. Okay, this electric motor's mechanism of producing a torque using a current. Okay, and electromagnetic induction mechanism of producing the EMF using a torque, right? Both these things happen together. That is what we call as back EMF. So according to this equation, you can say back EMF is maximum is not operating. That is wrong. When it is not operating, there is no back EMF, right? Begin its operation is also wrong, right? So it is maximum when it is at its maximum speed, right? Because this omega, when this omega is at its maximum, this will be at its maximum, right? It's simple as that, right?